All right, double replacement and acid base. So here is an areneous acid, and it's an areneous acid, at least at this point in time in the class, you can recognize that because there's hydrogen on the front. And that would be the case except if it's water. Water we don't usually call an acid, although technically it can be an acid. And then we're putting it with, what was it, calcium hydroxide? Is that what I put on the board a minute ago? Calcium hydroxide? Okay. Yeah. All right. Yeah. All right. So then we've got to predict the products. Is this compound acidic or ionic as opposed to something else?
That question.
Yes.
How do you know if it is acidic?
Well, let's see. You can tell it's ionic because of the polyatomic ion, except the hydrogen on the front makes it acidic. Okay? A compound that's made of metal and nonmetal is ionic. A compound that contains a polyatomic ion is ionic, except when there's hydrogen on the front. That makes it an acid. Okay? So it's acidic. Does everybody see that and agree with that? Okay, if you're just sitting there waiting on me to do it, and, you know, maybe sleeping back there, you know, you're not getting much out of this. Okay? So if it's ionic or it's acidic, it's a two-part compound. What are the two parts in this compound?
Metal and non-metal.
Not in that one. Not in that first one. What are the two parts in the first compound? Hydrogen and what?
Phosphate.
Hydrogen and phosphate. There's the hydrogen, there's the phosphate. That's the two parts of that compound. We could call that A and B parts. Okay? How about this one? Is this acidic or ionic as opposed to anything else?
Ionic.
It's ionic, he says? How do you know that?
Because does it have hydrogen, or is it a non-metal?
While these are non-metals, that's not the reason why this would be ionic. This is ionic because of the polyatomic ion. All right, let me review again that any time you have more than two elements, get out your test references and look on the common ions list. Everybody, get out your test references and find your common ions list. If you have more than two elements, where's the first place you look in your test references? Common ions list. So look on the common ions list and see if you can find a part of that formula that is a polyatomic ion. Hydroxide. There's the polyatomic ion. So that's going to tend to stay together from one side of the equation to the other. That doesn't mean it does it every single time, but almost all the time it tends to stay together. At least in this class, that's the way we're going to do it just about every time. There's hydroxide right there. That looks like this part of this formula. So if it tends to stay together, that's one part. So I need to find the other part, and that's calcium. So this would be like C and D. Okay? What's going to happen in a double replacement reaction is the front part of one compound is going to join up with the back part of the other. The front part of this compound is going to join up with the back part of this. Okay? So the first thing we're going to do with a double replacement reaction is to switch things around. The thing to remember, subscripts only travel. Subscripts only travel when they are part of the formula of a polyatomic ion. Okay? So this subscript isn't going to travel. It's not part of the formula of a polyatomic ion. However, this subscript is part of the formula for a polyatomic ion. The phosphate ion is P O4, 3 negative. So this 4 has to travel. This 2 is not part of the polyatomic ion hydroxide. Hydroxide is OH. Okay? There's no 2 in the formula for OH. The 2 doesn't travel. The OH travels, but the parentheses means I have 2 of them. It doesn't mean that the 2 belongs as part of the polyatomic ion. So we're going to put the front part of this with the back part of that. Okay? And we're going to take the front part of this and put it with the back part of that. Now all I've done is just switch them around at the moment. I have not balanced the formulas. Okay? Or haven't checked them to see if they're already balanced. I haven't done any of those things. All I've done at the moment is to put those together like that. Okay? The first thing I want to know is, do I have a driving force? Okay? Can anybody tell me if I have a driving force? How do you know we have a driving force? This is water. Okay? I know this reaction will take place because I've formed water here. Okay? So I need to do everything else. I need to balance the formulas, identify the physical states over here, balance the overall equation with the atom inventory. Okay? Alright, so this is you should know enough about water at this point in time to know this is already balanced. 2 waters, 1 oxygen, that makes 2 hydrogens, 1 oxygen makes water, H2O, right? So this is already water, and in an acid-base reaction, that's going to be a liquid. Okay, we don't have a lot of heat, as in a combustion reaction. In a combustion reaction, you generate a lot of heat, water becomes a gas. But in a double replacement reaction, most of the time, we just have liquid water. We still need to know the physical state of this, and then we still have to balance this. So I need to know the charge on the phosphate and the charge on the calcium. Where do we find those things? All right, the calcium you find on the periodic table with oxidation numbers. Because you can't balance the formula without them. You need to have the overall formula have a 0 charge when we're done. It needs to be neutral. So that's all that mass, balancing stuff we started out in Unit 3. Okay, I'll show it to you again. But let's look first on the periodic table with oxidation numbers and find calcium. So here's calcium, and if you look, it says it's got a 2+ charge. Okay? So our calcium then has to have a 2+, it's a 2+ ion. It's the only one, it only has a 2+ charge. There's no other charges you can have on that. Now we need to find the charge that goes on the phosphate. Where do we look for that? Common ions list is where we want to find that one. There you go. Okay, so look on your periodic your list of common ions and find phosphate. The more you practice with this, the better you're going to be on this on tests. Find phosphate on the common ions list. Okay, I'm just giving one person who was asking a chance to look. You located it? Okay, so it has a 3 negative charge. It's PO4 with a 3 negative charge on there. Okay? And the way we did this mathematically was we said we're going to put this 2+ in parentheses and this 3 negative in parentheses and put this same plus sign between them, and we're going to put sort of coefficients in this math problem as well. And what we want is to have the whole thing equal 0 when we're done to show that neutral charge. So my my superscript on this calcium that has the charge, I'm going to make it a large number here in parentheses. The 3 negative here, charge on the phosphate. I'm going to make that a large 3 negative in parentheses. And I just want to find coefficients to go here and here to make the whole equation equal 0. And I need a 3 and a 2. And that will give me 6+ plus 6 negative. And I think you can see now that does equal 0.
Will you ever get something that is like 2 positives?
And you can't do that. No. Because compounds, you want to equal 0 when you're done. Now, there are things you can put together to have a charged particle. We haven't done any of that at this point in time. But there was a definition in Unit 5, I believe, that said, what is the oxidation number? Let's see, what's the sum of all the oxidation numbers in a polyatomic ion? The charge on the ion is the answer. Okay, so if we were to add up all the oxidation numbers for the atoms that are in this polyatomic ion phosphate, all the oxidation numbers on the phosphorus and the 4 oxygens, we would get a 3 negative when we added them up. Okay. All right. So we want 3 calciums, and we want 2 phosphates, and when we bond them together, we don't use coefficients anymore. When they're bonded together, you use subscripts to show they're bonded together. So we need 2 calciums. I'm sorry, it's 3 calciums, isn't it? 3 calciums and 2 phosphates. Okay? All right, so we've got the formulas balanced, but I still need to know the physical state of this compound. We know there's water around because it says aqueous on these, and there's a liquid here, liquid water here. So there's water around. We have to use the solubility rules to figure out if this is going to be either aqueous or a solid. So we need to find either calcium or phosphate on the solubility rules. Okay, and just to speed things up in this class, I'm going to tell you calcium is not listed on here, but phosphate is. So find the phosphate. Everybody found it? Insoluble. Okay, phosphates are insoluble. So most phosphates are going to be solids. The exceptions would be when phosphates are bonded with a group 1 metal. That's not group 1, that's group 2, so it's not that. Or when phosphates are bonded with ammonium, and that's not ammonium. So there's no exception for calcium. So the phosphates has to remain a solid. So we'll put solid here. Okay? All right. So we've got the products predicted. We determined there's a driving force. We have the correct physical state, and we've got the formulas balanced. We're ready to balance the equation. So a lot of things to do before you get to the point where you can balance the equation. Okay, we have to, in fact, the first thing we had to do was determine that this was possibly a double replacement reaction. Before we do anything else, you've got to do that, because you don't know how to put everything together over here unless you know it's a double replacement reaction. So we're going to identify the kind of reaction. We're going to put the products, just the pieces, together over here. Identify the driving force or lack of it, and sometimes you have to find out whether it's solid or not to do that. Make sure you've identified the physical states over here, and you balance the formulas. When you get all that done, then you're ready to balance the equation.